Alrighty, let's start looking at this. We're going to be getting really into our last chapter today. But this factoring stuff comes up over and over and over again in this chapter. So, let's remember how to do this. On this first one, this trinomial is on the left guy. This one. What do we do? Yeah. Ooh, there we go. We've got our A that's with our x squared. We've got our B that's with the just x. And we've got our C that's all by itself. What are we going to do with those guys? Put them in the x thing. This is when we put our A times C at the top and our B goes at the bottom. So we already said that our A was with the x squared, so it's going to be the 4. Our C is the 9. So 4 times 9 gives us 36. B goes on the bottom, it's the 12. So we're looking for a pair of numbers that multiplies to make 36 and adds to make 12. 6 and 6. So can we take the shortcut on this one, or do we have to do it full out? Full out, because we have an A that's not 1. So we're going to use our box. The 4x squared comes from our equation. That's this guy here. Our 9 comes from the equation. This guy here. The only things that come out of the x frame are these two numbers on the side, and they each get one letter from that middle guy. So we'll have our 6x and our 6x. So what are our factors going to be here? Mm-hmm. 2x.
And then one next to it, I got 3.
Mm-hmm.
And then on the left,
Yep.
I got 2x.
Uh-huh.
And I got 3.
And we got 3 again. So our factored form, I could write it as our 2x plus 3. It's our top guy. And our 2x, that's a 2, plus 3. That's the side guy. That is definitely one way to write it. Totally valid. What's the other way I could write this statement? Yeah. We could make this be 2x plus 3 squared times itself. Both of these ways of writing it are 100% correct. There are going to be times when one is handier than the other. There are going to be times when we see one instead of the other. Just because of different ways of writing things. But they mean the exact same thing. Very similar vibe for the second one. Very similar vibe. What do we get as our final answer on this one? Not quite. 3x minus 5 is definitely going to be an important part, but it is not the only piece we're going to get. So give this one a try. It's a very, very similar vibe. Remember that we have our A that's with the x squared, B is with the x, and C is the just number.
Difference of squares.
It's a difference of squares.
3x plus 5 and then 3x minus 5.
So be really, really careful, because when we have two terms here, this is actually going to be our difference of squares. Again, you can do that entirely in the x in the box, exactly like the way we did the first one. Or we can go, hey, wait a second. The thing that gets squared to make 9x squared would be 3x times 3x will give us our 9x squared. The thing that's squared to make 25, we'd get a 5 and a 5. One gets a plus, one gets a minus. If we have something that's a perfect square here and a perfect square here, and we're subtracting them, you can use this pattern. Absolutely. And it's just whatever is squared to make the front. So 3x times 3x would give us 9x squared. And 5 times 5 gives us that 25. So with difference of squares, you can do it just like this. You can also do it like this. If you don't remember this, totally valid to do this over here. Just watch out on our signs. Okay. Questions on this one? Okey-dokey. So we are going to be in the notes packet. Does anybody not have the notes packet I gave out on Friday? Boop. So we're going to be on page 3. This is going to be kind of the start of our real part of this chapter. Friday was very much review on the factoring bit. But what we're going to be working with and what this whole chapter about is something called a rational function or rational expression. And all that is it's going to have x's in both the numerator and the denominator. But it's the denominator one that causes us problems. Because we don't like to have x's in the denominator. It's icky. It just makes things gross. And we've tried really, really hard to never have x's in the denominator before. Well, now our problems are going to come with them in the denominator, so we've got to figure out how to deal with them. So that's what our whole last chapter is about, is dealing with when x is in the denominator. So this little kind of paragraph situation is straight up from the textbook. It was copied and pasted and just put into a less aggressive form. And so all it is that a rational expression is just a fraction, usually of two quadratics. It might be like a cube and a quadratic, or it could be a quadratic and a linear. A lot of times they're going to match, but not always. And so it's just that we have two polynomials in a fraction together. What we're going to be doing today is we're going to work with simplifying. And there's a little example in here of like traditional, old school, doing it by hand, not typing it in the calculator, simplifying. Where if we had a fraction that was 35 over 45, and I asked us to simplify it without using the calculator, because I'm horrifyingly mean, we would notice that both of those could be divided by 5. So I could write this as, and a mistake here, because that's really 5 times 9. That makes 45, not 5 times 8. Because 35 is 5 times 7, and 45 is 5 times 9. But the 5s cancel out, right? Whenever I have terms that are being multiplied together, we can do canceling out. Just like if I had 4/6 and I wrote that as 2 times 2 over 2 times 3, I could cancel out the 2's. As long as we have multiplying, we can do canceling out. Which is why when we have something like a rational expression, that's what this guy is. I can't come through here on this example and cancel out my x squareds. That does not work because we have addition and subtraction. We can only do canceling out when things are being multiplied. So we have to write them in factored form because this is a piece times another piece. This is a piece that's times another piece. So when it's in factored form, it's written as a product, which means we can use our canceling out stuff. So we're going to have problems like this that in order to simplify, we're going to need to factor top and bottom. The other important thing about rational functions is we run into some extraneous solutions. In particular, when we look at our denominator. Because what is the one number in the entire existence of the universe we're not allowed to divide by?
X.
As a letter. It was like we're going to be dividing by x. It's kind of what this whole chapter is getting us ready for. 0.
Oh.
If I divide by 0, that's when the calculator gets really, really grumpy. It gives us a domain error. So we can't divide by 0. So we're going to have a lot of questions where we're going to have an excluded value, which is when our denominator will equal 0. So I'm going to put this as cannot divide by 0. And we'll talk about that here in just a second. So we have to be careful here. So let's look at the first one on this where it asks us to simplify just below here. And we give the expression that says 6 times x squared or 15 times x cubed, and we're asked to simplify this.
They have the GCF.
They do. They have a greatest common factor. And that's really what we're looking at a lot of times, is finding something that's common between these pieces. So when we have things in common like that, that's entirely what we're looking for. So I'm going to rewrite this, factoring that out and then canceling. One of the ways to think about these being written as products, this is the long way, is to do this as 6 being 3 times 2 and x squared being x times x. And then I could write 15 as 5 times 3 and x cubed as x times x times x. So you can do it like this. This is the full out long way. And then we can cancel things out because I have the 3 and the 3 that'll cancel out. I have an x and an x that'll cancel out. And I have an x and an x that'll cancel out. So what we're going to be left with is, in the numerator, the only thing that's left there is a 2. In my denominator, I have a 5 and an x. You do not have to write it out fully. Other option for writing this out would be if we took our 6x squared and our 15x cubed, old school simplifying style, where we do it 2 and 5 because we divided both by 3. And then we rewrite that power. So this is writing it as a mostly shorthand. This is writing it full out. They both get you exactly where we are here. And I don't really care how it works for writing. You can do a blend of the two. It doesn't really matter. The other important piece for us to have on here, questions on our canceling out bit up here, just before I move on. Our last line on this space is the other important piece here, because this is undefined when the denominator is equal to 0. So on this little statement, when it says the expression is undefined when blank is equal to 0, it's whatever statement's in the denominator. So when 5x is equal to 0. If that equals 0, our calculator's going to get an error, because I cannot divide by 0. So when 5x is equal to 0, we would solve that around. Well, 5x equals 0. If we divide both sides by 5, we get that x equals 0 divided by 5, or 0. So whatever piece is in the denominator is going to be a problem when it comes to our domain. It gives us a domain error. So when we have just monomial pieces, just 6x squared, 15x cubed, numerator and denominator, it's a simple method of canceling out. More often than not, when we have these problems, they're going to look more like the next one. Questions on this first one? So this is going to be more frequently how we see these styles of problems, where we have a factor on the top. So we have a linear function up here, x minus 4, and we have a quadratic function up here. I have x squared minus 7x plus 12. I cannot go through right now and cancel because we have only things that are being added and subtracted. So what we're going to do is we're going to look at this and say, well, this x squared, I can make this be a product. I can try and factor this. And that's exactly what we're going to do, is we are going to come through here and we're going to redo our fraction, and we're going to factor our denominator. So I'm just going to bring my numerator down, my x minus 4, and we want to factor this thing, which means I'm going to use my x. I might need the box. We might not. We'll see. We want to try and factor this thing. That's when we're doing just like in the bell work. A times C at the top, B on the bottom. That's going to give us a 12 at the top. B on the bottom is -7. What pair of numbers do we know that will multiply to make 12 and add to make -7?
-3 and -4.
-3 and -4. Multiply to make a positive 12, add to make a -7. Do we need to use the x here, or can we use the shortcut?
Shortcut.
Yes, I meant to say the box. We did use the x. The box. It's Monday, it's early. I get it. So we can use the shortcut where we just have our x with each of these numbers. So we're going to have x minus 4 and x minus 3. I want that one in pink. There we go. Now what do we notice?
They both have x minus 4.
I have an x minus 4 up here as well. I can put parentheses around it and make it look exactly the same. I have an x minus 4 on the top and I have an x minus 4 on the bottom. What that means is I can cancel this chunk with this chunk. What's that going to leave me in my numerator? If I cancel everything out, what's left up there? 1. Good. And our denominator is going to be just this little guy that's left over, this x minus 3. So this is our simplified function, our simplified expression. Questions on the simplifying part? She got a blender running over there? What the heck's going on? Our last bit up here, we're going to say the expression is undefined when our denominator is equal to 0. So we're going to take that whole chunk that's in our denominator because this is our piece that could potentially give us problems. So when x minus 3 equals 0, we have a problem. Because if that equals 0, I'm trying to divide 1 by 0, so it's a problem. So x minus 3 equals 0 would be what? What would our solution be here for that?
X equals 3.
X equals 3. So the expression is undefined when x minus 3 is equal to 0 or when x is equal to 3. This is the more important part, but this is kind of helping us get there. This is going to wind up being an asymptote on our graphs of these.
Graphing thing?
We will be graphing these eventually. Yes, we will. I know. It's almost like this packet is chunky for a reason.
I should have known.
I mean, you could flip through.
Yeah.
Start graphing in like a week. I was going to say the first graph is, I want to say page 10. Maybe page 9. Or maybe, yeah, 10 is where you see the first graph. We're on page 4 now. So we're not far from it. We've done all the things like we need to for it. There's not tons new on the graphing bit. All right, so let's look at this one. Very next page, page number 4. 451 is from the textbook. This is, in fact, a textbook example. But it is page 4 in our packet. So, I'm just double checking. Okay, cool. Now I have more pieces. Ew. Doesn't change what we're going to do. I cannot do any canceling out when we have just adding and subtracting. We can only cancel out when pieces are being multiplied. So we're going to have to factor our numerator and we're going to have to factor our denominator. Ew. I told y'all factoring was going to be a huge thing in this one. No slang. All right. So we have 2 different quadratics up here. So I will do the top one in green. So let's factor this guy. So if I'm looking at that green one, my a times c, 1 times -24, and our b is -2. Do we know a pair of numbers that's going to multiply to make -24 and add to make -2? -6 and +4. Good. Since we have an a value that's 1, we can use our shortcut. We don't have to do the whole box. If you want to, totally valid, but it's going to give you the exact same answers of x minus 6 and x plus 4. We love that. And then I know some of us noticed, but can we notice it again on this denominator? What do we see? We've got, it's cubed, ew. Ugh. But what else do we see? GCF. What's our GCF?
2x.
And an x. So let's see what happens if I factor a 2x out. If I factor a 2x out, we're left with an x squared plus 3x minus 4. That one's doable. Way less gross because then I don't even have an a value left. I just have the chunks. So I'm going to bring my numerator down. My x minus 6 still hanging out. My x plus 4 is going to hang out. In our denominator, our 2x is going to hang out. And then let's factor that guy. Our x squared plus 3x minus 4. So looking inside here, we again have an a of 1. This time we have a c of minus 4. So we have minus 4 on the top. And our b is a positive 3. What's a pair of numbers that multiplies to make negative 4 and adds to make a positive 3?
4 negative 1.
4 and negative 1. So we'll have our x plus 4 and x minus 1. Again, since we don't have an a value, we can take that shortcut. I love that shortcut. Yeah. Because our next thing is that we're looking to see what they have in common. So we're looking in here, in this pair, just because we have a couple of the same colors in a row. And we see that they both have that factor of x plus 4. So this guy is going to cancel out with this guy. And our simplified answer, what we can get this down to, the smallest it's going to be, is that x minus 6 in the numerator. And then we have 2x times x minus 1 in our denominator. So this is our fully simplified answer. This is as simplified as we get. Yes, dear.
So when you're doing the greatest common factor, you can always put the greatest common factor on the outside. So that's still like kind of.
It still counts as times. And you could, if it bothers you, if you don't like that, you can put parentheses around it. That's totally fine. If that helps you, absolutely cool. But since it's pressed against it, it is being multiplied. But
And that's only the greatest common factor.
yeah. Because those are both still times. Okay. Our last bit on this one is to figure out where our expression is undefined. And we're undefined wherever this denominator equals 0. So whenever 2x times x minus 1 equals 0. This is going to be one of the only times we see this, but this is going to have two different options here. Because this in and of itself is a quadratic statement. There's two pieces. If I set this up and write it down as our 2x times x minus 1 equals 0, we have two different solutions here. Back in quadratics, that's when we split it into our two separate pieces and make them both equal to 0. So it's either going to be when 2x equals 0 or when our x minus 1 equals 0. So our two possible places where we're going to have problems, we have when x equals 0, because that's what the 2x1 is going to give us, divide both sides by 2. Or x minus 1 equals 0 gives a solution at x equals 1. We are not going to super frequently have two statements in our denominator, just because that makes the graphs so much more complicated. But it can happen every now and then. Let's do one more, that last one on page 4. And this will be the last one. So here we have x squared plus 2x plus 1 over 4x squared plus 3x minus 1. So huzzah, only squares, we like that. So let's try and simplify this. I need to try and factor my numerator. I need to try and factor my denominator. I can only cancel stuff out when it's in factored form. So let's look at our numerator. I do yellow and green. So when we set up our x frame for that guy, our a times c, our a is 1, our c is 1, so we get a 1 on the top, and our b is a 2. So we're looking for a pair of numbers that multiplies to be 1 and adds to be 2. What pair of numbers multiplies to be 1 and adds to be 2? Yeah, 1 and 1. So as a factored form, you can write this as x plus 1 times x plus 1.
The bottom one is funny because it's basically, the first part is basically the same as the one we did on the last one, the -4. What multiplies to equal -4, that's positive.
I know. We'll have a lot of times where we see some very similar numbers. Even then, they may wind up with some vastly different answers, though. So looking at our bottom one, looking at our denominator here, we're looking for our a times c, our 4 times a -1. That's giving us a -4. And our c of +3. What's our pair of numbers that multiplies to be -4 and adds to be +3?
4 and negative.
4 and -1. We've seen that pair before, but we have different factors here. I cannot just put that same factored form because we have this a of 4. I need to use my full set of tools. We need to use some sort of factoring tool to help us get this factored down. When we have an a that has some sort of value to it, we've got to use the whole kit. So we need our 4x squared that's coming for our equation, that's coming here. We need our -1 from our equation, that's going to go here. And then our two numbers from the box, those are getting that middle letter. So we're going to have our 4 with this x and our -1 with this x. What are we going to get as factors? Columns and rows.
X plus 1 is on the top.
X plus 1.
4x minus 1 is on the side.
4x and -1. So be really careful. I told you that factoring stuff was gonna come up. Here's our very first time that it's really coming up intensively. So we need to be able to factor. That was just our setup for this problem, was to factor it. Because what we're really wanting to do is this cancellation step. What can we cancel out up here?
We can cancel out 1 of the x plus 1.
One of the x plus 1s. This guy can cancel out with this guy. I cannot take out both. It's a one and done situation. So our simplified answer here is going to be our fraction that has x plus 1 in the numerator and 4x minus 1 in our denominator. I don't know why I'm doing my 1s differently. But that's okay. It's a 5. And our last bit, the very last thing for today, is this expression is undefined whenever whatever expression is in our denominator is equal to 0. So for this particular case, it's when 4x minus 1, this chonker, whatever's in the denominator, when that is equal to 0. So we need to set that equal to 0 and get an actual value. So 4x minus 1 equals 0. What do I do to try and figure out what x needs to be for that?
Add 1.
Add 1 to both sides. So we have our 4x equals 1. What do we do then?
Divide by 4x.
Divide by
4.
just the 4. So when do we have a problem when x equals what?
X equals 1/4.
1/4. So x equals 1/4 is where we're going to have a domain error. So we need to be able to factor these things, and we're trying to simplify things out. Okay? Questions on this one? So, test it.
On there it says it's due tomorrow.
Yes, that would be because the date on this slideshow did not get adjusted after the surprise day off last week. So I'm adjusting it now.
You can check that I'm doing.
Mm-hmm.